Okay, so here we are. This is exam 2, part 2. Basically asking us to calculate the net flow rates and root find and constrain the net flow of the internal nodes to 0. So the first thing that we need to do in this situation is define our entire situation. So we're going to make an array of pipes. So we're going to have from node 0 to 1. And our length is going to be 20 for that pipe. And our K value is going to be 1. And then I'm just going to go ahead and make my life a bit easier and just keep that copied. And this is going to be from node 0 to 2. And then the length is going to be 30. K value also is going to be 1. And then our next pipe is going to be from node 1 to 2. And then our length is going to be 5. K value is also going to be 1 here. And then we've got a pipe from node 1 to the environment, which we're just going to label node 3 in this instance. And it's got a length of 0.1 and a K value we're just going to guess because that's what the problem statement says. It says to guess 6. So that's going to be our K value. And then our last pipe, our fifth pipe, is going to be from node 2 to 3. Its length is also going to be the same as 1 to 3, so 0.1. This is in meters, all SI units. And that doesn't need a comma because it's our last one. Okay, so now that we got our pipes labeled here, our whole situation outlined, what we can do is also label Z values, our height values. So we're also going to put that in an array. And it says that a good guess for this one, for node 0, is 15 meters, and that the rest are 0. So there's our Z values. And now what we can do is specify which nodes are external. So external pressure indices. And this is from 0 to 3. So 0 is an external pressure indice, and 3 also is external pressure indice. Those are both external nodes. And then what we can do is create an array with their actual values. So external pressure equals np.array. And then they're both going to be 0 in this instance. Node 3 is going to be 0 because that's the environment, and node 0 is going to be 0 just because that's what the problem statement tells us. So our from node, what we can do is, for calculation, we can pull each of these, since Python indexes in strings, we can pull each column out. So from nodes, to nodes, our lengths, and our K values, we can just pull all of those out and specify them as integers. So here's our from node. We're pulling that out of the pipes array. Column 0. And then as type, integer. Okay, so that we can do the same thing for to node. I'm just going to go ahead and copy that. And this is going to be column 1. But this is going to be to node. And then the next thing that we're going to do is our lengths. That's column 2. And then after that, our K value. And that is going to be, well, column 4, but indexed is 3. And then the next thing that we're going to need for our calculation is actually the number of nodes. So how many nodes do we have? Well, 4. So that's easy. In nodes equals 4. And then we're also going to need to get the number of pipes. Now, we also know that we have 5 pipes. But just for fluidity, if we were to add any other pipes to this, what we can do is use the pipes.shape we can use pipes.shape to get the shape of the array, the pipes array, which would give us the number of indexes. Since this is one pipe and this is one pipe, basically each index is a pipe. So if we were to add any more pipes to this, it would automatically catch it and we wouldn't have to modify our code. But we would have to modify the number of nodes in this instance. Now the next thing that we're going to need is pipe diameters. So pipe D, we're going to go ahead and specify that. And these are all going to be in the same kind of fashion that they are in the pipes array. So like for example, this is for pipe 0 to 1. So like pipe 1, pipe 2, pipe 3, so on and so forth. And you could just use the fill function, but since they're all different, we're going to actually have to create an array here. And I know from node 0 to 1, so I'm going to label this as pipe 1, pipe 2, pipe 3, oops. Okay, so 1, 2, 3, 4, and 5. So this is the only one that's different. All of these are 0.01 and this one is 0.10. Okay. I'm going to go ahead and consolidate that. Alright, so it also says, our problem statement also tells us that epsilon over d, epsilon over diameter, so surface roughness over your diameter, for everything a good guess is going to be 0.001. So we're just going to make an array here with that, and we're just going to use the full function. So there's that one. And what we can do now is specify our internal indices. So which nodes are internal nodes. And we can use the set function, like set subtraction, to find that. And then we can just subtract the external pressure indices from this, and that would give us what our internal indices are. Now Python sometimes doesn't like to work with just sets, so we can transfer this to a list just for fluidity, because you know coding is weird sometimes. Let's see, did I forget I feel like I have an extra not comma, but parenthesis in here. I feel like I do. Because this should be one thing. Let's see, this one corresponds with this. Yeah, I do. Okay. And then we can find the number of internal indices using the length function. And also we could have just put in numbers for this, but if we modify the code and in any sort of fashion, this keeps it to where, or not the code, but if we modify the situation, this keeps it to where we don't have to modify any base things about the code. It just, it just works. So we're asked to calculate flows and net flow rate. So what we can do is create empty empty arrays here for those values to go into. So then there's our flow rates and here's our net flow. And then here's our pressure. Basically we're just filling these arrays just with zeros, just so that we can replace them. And actually what we can do now is just go ahead and replace the pressure with the external pressure. So using the external pressure indices, we can just go ahead and put the external pressure in there. And now for root finding, what we're going to need is we're actually going to need a guess to find the roots for this based on the Python function. So we can go ahead and put our internal guess in here. So our internal pressure guess, and that's just going to be the we're gonna make an array full of values, and the shape of it, we're just going to put the number of internal indices because we're only trying to calculate flow rate for the internals. Or pressures for the internals, sorry, not the flow rates. And the easiest thing to do is just use the mean as a guess. The mean for the external pressure as a guess. Okay, let's see, what did I do here? From node, in 32 is not defined. In P. There we go. Alright, that fixed our issue. Okay, so now we can make a function to find our flow rates to 0. So this basically is just a correction constraining this. And we're going to put our guess in there to find that. That's what our internal P is. We can go ahead and put our internal indices in here. That's going to equal our internal pressure. Not guess, just pressure. And we can go ahead and calculate heads for each there. So pressure over density over gravitational constant plus z, our height. And to find delta head here, we're going to use a for loop, so for I in range, and we're going to use the number of pipes as the range. And then we're going to do delta head is equal to heads, 2 nodes, so the head on the 2 node, using that specified whatever portion we're at, and then minus the head from the from node, using whatever indice we're at there. And then for flows, we can go ahead and modify that one. And then we can use the function that we made in part 1, using delta head as our head pressure there. So lengths, and that's the array that we pulled out. And then basically these are the arrays that we pulled out of the pipes array, given whatever the current pipe that we're on, which is the I value. So there's that. And now what we can do is fill an array, fill it with 0, so that we can replace it. And what we can do is go ahead and add values to it at the end of this function at a specific location. And we're going to add it to the net queue, which we just filled with zeros. And for the 2 node, it's just going to be flows. So we're going to add. And then we're going to do the same thing for the from node. But the difference is here we're going to put negative flows because it's in the opposite direction. And now we can go ahead and return our function. So return net queue, and then internal indices, because that's the only thing we're looking for. It's just the internal pressures. And there's our function. And we can go ahead and use the root function now. So the result is equal to the root q to 0, and then internal indices as our value. Let's see, what do we do here? Doesn't like our delta head calculation. Integer and Boolean array. Okay, so it only wants an array. Let's see. So if it only wants an array, let's see, we can make this an array. This is one of the ones that's not an array yet. So we can use the max function actually. For this, to find the max number, and then as type np.int32, and that's what our nodes are going to be there. So let's see if that fixed our issue. It didn't. Okay. Let's see, where did we go wrong here? We specified this twice. I didn't relabel this. This was supposed to be lengths. Okay. There we go. Okay. Okay, so now what we can do, since we're pretty much done with everything now, all we got to do is just print our results. So we can do for I in range for our number of nodes. And then we can go ahead and print values. So we're going to go ahead and print the net flow. And then I'm going to go ahead and print the actual value for the net flow. Now the net Q is just a label. This is supposed to be brackets. And then we're going to use significant digits. Okay. And then we can print the pressure on the same line. Okay, so there's that. And then we can go ahead and print just a space in there, just as like a filler. And then we can basically do the same thing that we did. So for I in range in pipes, and this is just going to be printing the flow rate from the pipes, not net flow rate, but just the flow rate in general. Okay, so that's going to print the flow rate. That's going to be our label there. So like from whatever to whatever. So like 0 to 1, 0 to 2, 1 to 2. So then we're going to use toNode here. And then the same thing, which is I. And then we're going to do that, a colon. And then whatever our value is. So flows I to actually get the flow rate. And then we're going to use significant digits on this one as well. And then we're going to label that as meters cubed per second. And then there we go. Shift enter. See, invalid syntax. What do we do? What do we do? Ah, colon. That doesn't seem quite right. That's the spacing I was going for. Okay, cool. So our net flow on node 0, our net flow to the environment, our pressures that we're looking for here. And there we go. That's it for part 2.